Hi, it's Renata Ortiz and Gabriel González. We're going to be talking about exoplanets. First of all, what is an exoplanet? An exoplanet is a planet that is outside our solar system, and it typically orbits another star in our galaxy.
How do we find exoplanets? Well, there are 5 methods that scientists commonly use to discover exoplanets. And the 2 main techniques are the transit and the radial velocity methods. The first one, the transit method, is like when a planet passes directly between an observer and the star, it orbits, and well, it blocks some of that starlights from a brief time. So what do the observer do is to check those alterations in the brightness of the star, so they can assume what is passing in front of them, like what planet is passing and how it is composed. And the other one is the radial velocity method. And this is kind of like the Doppler effect stuff. It changes like its frequency of the color, and it changes between blues and reds, so they can see like how the star is moving, because as we know, the star have a force of gravity to the planet, but the planets also make gravity over the sun, so it moves the sun or the star, and that is how they know what exoplanets are around that star. Types of exoplanets.
The first type of exoplanet is the gas giants. And these are planets that are even larger than the biggest planets we have in our solar system. They are so close to their star that they reach very high temperatures. They are so hot.
Well, about these ones, these are like the Jovians, like planets, the Jovians planets that are alike to Jupiter, and normally they are far from the sun, where they can have these gases or this dense atmosphere. But there are some weird Jovian planets that are too close to the sun, and they are still gas planets, and these are like, this is weird, and this is kind of the point of what we're talking about then.
Neptunian planets. These planets are similar in size to Neptune or Uranus in our solar system. And they have a lot of mixture of compositions, but they all have hydrogen and helium dominated outer atmospheres and rocky cores. And we don't have any of these types of planets in our solar system.
The super-Earths. The super-Earths are typically terrestrial planets that may or may not have atmospheres. They can't know about it yet, because the atmosphere, well, those planets aren't as big as the Jovian planets, so they can't measure the composition of the atmosphere, because they took like, in the Jovian planets that are so big, they have to take like one photon between like 1,000, and they analyze that photon, and they check if those are kind of some elements, like some elements absorb some colors, and then as you see the color frequency in the image, you can see that there are some missing colors. So when you check what are the elements that absorb that colors, you can know from what elements the atmosphere is composed, but they can't analyze the atmosphere of these super Earths, and they can't also analyze the terrestrial planets. And well, the terrestrial planets are Earth-sized planets or smaller than the Earth. They are composed of rocks and silicate and water of carbon. And well, as I told before, they don't know yet if they possess some atmospheres, oceans, or other signs of habitability, but is probable that they can be habitable. And I'm going to talk about the exoplanets mystery. As we saw, there are some mid mid planets between like Earth and the Jovian planets. It's like these rocky planets that are close to the sun and these gas giants that are far from the sun. There are some planets that seem to be missing in our atmosphere, or we don't we don't have the entire comprehension about how the atmospheres, how the planetary systems form, because we had this idea that all these solar systems form like these rocky planets near to the sun and these gas giants far to the sun. But we now see some Jovians, some hot Jupiters that are so close to the sun that they are almost kissing it. And this is weird. So they are now trying to understand from zero how is that planetary systems really function.
In conclusion, there's still so much we can learn about space, not only about our solar system. Among other things, investigating about the universe, it's important to find out more about life in general and to validate theories or create knowledge. We think we know a lot about plenty of topics, but maybe if we dig a little deeper, we're gonna find so much new knowledge. And even if we haven't found a planet that is completely capable of sustaining life, there's a big probability that it exists, and we may find it in a few years. Thank you for listening. Have a good day.